Welcome back to Saxon Math. This is lesson 70, reducing fractions before multiplying. Before two or more fractions are multiplied, we might be able to reduce the fraction terms even if the reducing involves different fractions. For example, in the multiplication below, we see that the number 3 appears as a numerator and as a denominator in different fractions. 3 is the numerator, 3 is the denominator. 3/5 times 2/3. 3 times 2 in the numerator would multiply straight across as 6, and 5 times 3 in the denominator would multiply across as 15. You would end up with 6/15, which reduces to 2/5. We may reduce the common terms, which are the 3's, before multiplying. We reduce 3/3 to 1 over 1 by dividing both 3's by 3. If this was 3 divided by 3, you'd get 1, and 3 divided by 3, you'd get 1. Recognize then that you have 1 times 2, which equals 2, and 5 times 1, which equals 5. By reducing before we multiply, we can avoid the need to reduce after we multiply. Reducing before multiplying is also known as canceling. Sometimes you can reduce the numerators and the denominators of both fractions. So in this case, you can recognize that 4 divided by 4 would be 1, and 8 divided by 4 would be 2. You could also see that 3 divided by 3 would be 1, and 9 divided by 3 would be 3. So that cancellation results in a 1 times 1 in the numerator and a 3 times 2 in the denominator. So you'd have your reduced fraction straight out of the gate. Otherwise, you would have 12/72, which would have to be reduced. You'd have to recognize that this is divisible by 12, and so is this one. You'd have to recognize that. Then you'd have to get 1 as that, and then you'd have to do 72 divided by 12, and notice that, well, you'd guess and check until you got 6. And 6 times that would be 72, and so you'd end up with 1/6 in the end anyway. It's a lot easier, instead of doing all this mumbo jumbo, to just start out with canceling when you can. Example, 5/6 times 1/5. So you could result in 5/30, but that's not what this assignment's all about. We're trying to actually cancel instead. So this 5 in the numerator cancels this 5 in the denominator. They're both divisible by 5. 5 divided by 5 is 1. 5 divided by 5 is 1. You end up with 1 in the numerator and 6 in the denominator. This would be your final answer. That would have been the same as 5/30, but you would then have to realize, oh, I can divide this one by 5 and this one by 5, and I'd get 1/6. Example 2, 1 and 1/9 times 1 and 1/5. In this case, I need to make sure that they're both fraction forms, not mixed numbers. So 9 times 1 is 9, plus 1 makes 10 ninths. 10 ninths is what 1 and 1/9 is. Times 1 times 5 is 5, plus 1 is 6 as the numerator, 5 is the denominator. Now I need to look at what can I cancel in this one. It looks like this 10 divided by 5 is 2, and 5 divided by 5 is 1. 6 divided by 3 is 2, and 9 divided by 3 is 3. So I can now multiply straight across. 2 times 2 is 4, and 3 times 1 is 3. This would be 4/3. The answer needs to be written as a mixed number because both of these products were mixed numbers in the first place. That'd be 1 and 1/3 is the final answer. Okay, and here they're just sharing with us that we could pair the 10 with the 5 and the 6 with the 9. So recognizing that you're just kind of flip-flopping both sides. You see that 10 and the 5 are related to each other. This is a numerator, this is a denominator. This one is a numerator in the 6, and this 9 is a denominator. So those would be connected, and that's what I did there, canceling those out. And it might not be as clear, but you can see that 6 times 10 is the same as 10 times 6. Therefore, you could have this. You could just have it this way as well. So 6 over 9 now is the same as what this is if you were to look at it. If we flip-flop the numerators, you'd still end up with this problem. These still end up with the same answer. So 60 over 45 is what it would be, but you can see this is easier to connect those, and it's easier to connect those. You see that this would become 2 over 1 when those cancel each other out, and this would become 2 over 3 when those cancel each other out. So that's what you'd end up with. Simplify 5/6 divided by 5/2. Well, when dividing by a fraction, remember you have to multiply by the reciprocal. So this is the same as 5/6 times the reciprocal, which is 2/5. Now that I have that, I should recognize that I would match these two up with each other. This would become 1 over 1. And I'd have to match these two up with each other. This would become 1 over 3 because 2/6. So now I just have 1 times 1 here, which equals 1, and 3 times 1 here, which equals 3. 1/3 would be the answer. So we may cancel the terms of fractions only when multiplying. A division problem must be rewritten as a multiplication problem before we may cancel the terms of the fractions. We do not cancel the terms of fractions in addition or subtraction. So do not cancel terms of fractions when you're adding and subtracting. If you're multiplying, you can do it. And if you're dividing, that's the same as multiplying by the reciprocal. All right, let's do these. Letter A, 3/4 times 4/5. It says reduce before multiplying. All right, in this case, I see 4 over 4 is the same as 1 over 1, and 3/5 can't be reduced. That would be 3/5 as the final answer because 3 times 1 is 3, 1 times 5 is 5. Letter B, 2/3 times 3/4. So here I see that this 3 over 3 would turn into 1 over 1, and then this 2 over 4 would be the same as 1 over 2. I'd end up with 1 in the numerator and 2 in the denominator for 1/2. Letter C, 8/9 times 9/10. You should have recognized that 9 over 9 is the same as 1 over 1, and 8 over 10, those are both divisible by 2. This would end up being 4. This would be 5. So in the numerator, you have 4 times 1, which is 4, and the denominator has 1 times 5, which is 5. Letter D, 2 1/4 times 4. You have to reduce before multiplying. You also have to write it in fraction format. So this would be the same, and let me just write this down here. So for letter D, I would have to rewrite 2 1/4 as an improper fraction. So that'd be 8 plus 1 makes 9/4 times 4. And 4 is the same as 4 over 1. So that would be what I need to do. This 4 cancels that 4 out. And now I have 9 times 1 up here in the numerator and 1 in the denominator. That would be 9 as the final answer. Letter E. So for letter E, let me just write that with orange right here. So 1 1/2 would be the same as 3/2 times, this would be 6 plus 2 makes 8/3. Now that I've got it written in fraction form instead of in mixed number form, I now see that 3 over 3 is the same as 1 over 1, and this 2 over 8, or sorry, 8 over 2 would be the same as 4 over 1, because 8 divided by 4, or 8 divided by 2 is 4, and 2 divided by 2 is 1. 1 times 4 for the numerator and 1 times 1 for the denominator. Anytime I have 1 times 1 down here, I know that whatever's in the numerator is going to be the answer. So that's going to be a whole number of 4. It could be 4 over 1, but the answer is going to be 4 as a whole. Letter F, 3 1/3 times 2 1/4. So this would be 3 times 3 is 9, plus 1 makes 10 as the numerator, and 3 is the denominator, times 2 times 4 is 8, plus 1 makes 9, and then 4 is the denominator. Now I should see that 3 and 9 can match up. 3 divided by 3 is 1, 9 divided by 3 is 3. 10 and 4 can connect. I can link those. Both are divisible by 2. 10 divided by 2 is 5. 4 divided by 2 is 2. I end up with, in this case, 5 times 3 in the numerator and 1 times 2 in the denominator. 15 halves. And because it was in a mixed number format, I have to convert this to a mixed number. 2 will go into 15 7 times with 1 left over, so it'd be 7.5. 7 times 2 is 14, that'd be 1 as the numerator and 2 remains the denominator. Letter G. It says rewrite each division problem as a multiplication problem, then reduce before multiplying. So in letter G, I need to rewrite that. That would be the same as 2/5 times the reciprocal 3/2, and then reduce before multiplying. So you should recognize that 2 over 2 is the same as 1 over 1, and 3 and 5 can't be reduced. That's all there is to it. So I ended up with 1 times 3 in the numerator and 5 times 1 in the denominator. So it'd be 3/5. All right, and letter H. 8/9 times the reciprocal of 2/3, which is 3/2. All right, so first of all, I see right off the bat, 3 divided by 3 is 1, 9 divided by 3 is 3. I can do both of these divisible by 2. 8 divided by 2 is 4. 2 divided by 2 is 1. So now I have 4 times 1 in the numerator and 3 times 1 in the denominator. I'd end up with 4/3, and technically it's in a fraction format, but I'm going to put it as a mixed number answer, 1 1/3, because I just like to have it that way. It would be technically right to say 4/3, but it's probably more proper to put it in this format, just because an improper fraction, obviously. Letter I, 9/10 divided by 1 1/5. So letter I need to take 9/10, that just stays the same. I have to multiply by the reciprocal of 1 1/5. Well, what's 1 1/5 as a fraction? This is a mixed number right now. I'm going to convert it into an improper fraction, and then I get to flip it. So 5 times 1 is 5, plus 1 is 6. 6/5 is the fraction. So now I have to multiply by the reciprocal of 6/5, which is 5/6. Now I can see that both 9 and 6 are divisible by 3. 3 divided into 9 would be 3. 6 divided by 3 would be 2. 5 and 2, both of those are divisible by 5. 5 divided by 5 would be 1. 10 divided by 5 would be 2. So I have 3 times 1 in the numerator and 2 times 2 in the denominator. So this would end up being 3/4 for my final answer. And that's not equal to 6/5, but that was just 6/5 as 1 1/5. All right, excellent work today. Make sure you do written practice lesson 70, 1 through 30. It's very important that you do each of the problems. You can't do 1 through 15 or 16 through 30 because Saxon works on previous lessons. It's the only way you get the practice from each of the lessons. Excellent work today. We'll see you next time.